Hello everyone. Today we are going to discuss the naming of compound, and this is a question from Desonil. You can see here we have some compound and we have to write down the name of these compounds. So before starting this question, I would like to discuss the content part of this chapter. So let's start the naming of compound. So naming of compound, organic compound. So there is a trend in Iupac. We have to write down the name of substituents, in alphabetical order, After that we can write word root, and then primary suffix, and in the last secondary suffix. Clear? So first we have to write down the name of substituent or branch in alphabetical order, then word root, then primary suffix, and then secondary suffix. So let me explain what is here the word root. Word root is called number of carbon in parent chain, parent chain. Primary suffix is of three type. Okay, primary suffix is of three type. N means single bond, in means double bond, and ine means triple bond. Clear? So whenever we have single bond in a compound, we can say ane. Whenever we have a double bond, ene, and triple bond means ine. Secondary suffix is a functional group. No need to memorize this, okay? It will be given in the stem. So whenever you have carboxylic, it is considered as oic acid. Whenever you have alcohol, it is called as ol. Whenever you have aldehyde, it is al. And whenever we have ketone, it is called as one. So these are some important ones. What is word root? I said that word root is the number of carbon in a parent chain. Suppose we have just one carbon, then it is called as meth. 2 carbon is eth. 3 carbon is prop. 4 carbon is but. 5 is a pent. 6 is a hex. 7 is a hept. 8 is a oct. 9 is non, and 10 is called as dec. 11 is undec. So this is good enough, okay? I think 11 is till 11 is a good one. After that there is no importance. So what is substituent in alphabetical order? Substituent means branch. Suppose you have just one carbon branch like this is called methyl. If we have 2 carbon branch like CH2 CH3, this is called as ethyl. If we have 3 carbon branch CH2 CH2 CH3, this is called as propyl. And if you have a fluorine, this is called fluoro. Chlorine, chloro. Bromine, bromo. And iodine, iodo. Clear? So whenever we have any compound, we can name in this way. First we have to write down the name of substituent in alphabetical order. After that word root, then primary suffix, and then secondary suffix. So here we have some rules as well. So let's discuss the rule 1. Selection of parent chain. So look at here, we have suppose any compound, then first of all we have to select a parent chain. So the priority in the parent chain is functional group has the highest priority. After that double bond, then triple bond, then maximum number of carbon. Clear? So we have to follow this trend, okay? We have to follow this trend. Means whenever we have any compound, parent chain must have functional group. If suppose more than one functional group, then you have to consider both functional group in the parent chain. It can be a short carbon chain as well. Look at few examples. Suppose we have this compound, okay, and this is a functional group called carboxylic. This is a functional group called carboxylic. So parent chain always be a carbon containing chain, means you have to include the carbon of carboxylic in a parent chain. So this is my carbon, so this carbon must be in the parent chain and this will be the parent chain. Why? Because this is the longest carbon with the functional group. Clear? How many carbon? 1, 2, 3 and 1, 2, 3, 4 and 5. So here we have 5 carbon parent chain. Make sense? Suppose we have this one. Look at here. Suppose you are going to start from this in 1, 2, 3, 4, 5 and 6. 6 carbon like this. There is another possibility 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is the way we can select a maximum number of carbon here, because there is no functional group, no double bond, no triple bond, only carbon chain. So you have to include the maximum number of carbon in this parent chain. Look at this one. So first of all, we have to see how many things are here. So there is no functional group. We have a double bond as well as carbon chain. So we have to include the maximum number of double bond in a parent chain. So maximum number of double bond will be this one. Clear? Makes sense? Suppose you have this one. Clear? This is a compound and we have to select the parent chain. So every dot is a carbon. This is carbon, this one is a carbon, this one is a carbon, 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 carbon and carbon. So here we have more than one functional group. So we have to include both functional group in a parent chain. So we can start from the any one. Suppose this carbon, 2 carbon and this carboxylic carbon. So you can see we have both functional group containing carbon in the parent chain. And how many carbon length here? 1, 2, 3, 4. This is also a carbon. So here we have 4 carbon parent chain. So if you are going supposed to be down like this 1, 2, 3, 4, 5. The down one is definitely the longer carbon chain, but priority is always decided by this effect. First functional group, then double bond, then triple bond and then maximum number of carbon. So here we have more than one functional group, so you have to include both. It can be a shorter chain as well. Now the next is, after deciding the parent chain, the next job is to find the numbering rules. So rule 2 is a numbering rule. So what is numbering rule? Here also we have priority. First you can write here, numbering always start from that end where these groups get the lowest number, means functional group, then double bond, then triple bond, then substituent or branch. With the lowest number, where the lowest number. Okay. So we can discuss this one in the previous example as well. Look at here. Let's do new one. Suppose we have this one. This is A. This is B. And this is C. Clear? So first we have to select the parent chain and then numbering. So look at the parent chain. Parent chain must have functional group with longest carbon chain. So this is my ketone functional group. So we can select this carbon chain as a parent chain. Here we have this double bond must be in the parent chain with longest carbon. And here this is carboxylic, so it should be in the parent chain. So we can start from here and then the longest carbon chain. Clear? So once you have a parent chain, then you have two choices to start the numbering. Either left hand means either this end of the parent chain or this end. You can only start from on the parent chain terminal carbons. So the rule is very clear. Priority is given to functional group, means we should start numbering from that end where the functional group get the lowest number. So if you start from the downside, 1, 2, 3, 4, 5. 5 is my ketone. And if you start from the upper carbon, 1, 2, number 2 is my ketone. So we can start from here 1, 2, 3, 4, 5 and this is 6. Let's do this one. So this time we have a double bond and branch. You can see this is, what is branch? Branch is a carbon containing or anything which is not the part of principal chain or parent chain. So you can see this outside carbon is not in the parent chain. So this is considered as a branch. So we can again start numbering from either this end or this end. So priority is given to the double bond. We should start numbering from that end where the double bond get the lowest number. So 1, 2, number 2 is my double bond. If you start from here, 1, 2, 3, 4, 4 is my double bond. So the correct way is 1, 2, 3, 4, 5 and 6. Now look at here, we can start numbering either bottom or top, but we have a functional group on this carbon, so always start from here 1, 2, 3, 4, 5 and 6. Clear? So this is the numbering of parent chain. Now we are going to start the naming of very simple one, the alkane compounds. Alkane means simple hydrocarbons which have a single bond. So let's talk about naming of alkane. Naming of alkane. So the first thing is selection of parent chain SPC. What does it mean? Selection of parent chain. So we all knew in alkane we have just a carbon chain only with a single bond. So parent chain rule is very simple. Longest carbon chain will be the parent chain. Longest carbon chain. Second is my numbering rule. So numbering always start from that end where the branch get the lowest number. Numbering always start from that end. Always start from that end where the branch get the lowest number. Look at the example. Here we have two compound and we have to write down the name of this. And the first thing is what? Longest carbon chain. So if you look at this one, the longest carbon chain will be this. And here the longest carbon chain, either this end, or you can start, you can start from this carbon to this as well. Clear? Both are same thing. You can see how many carbon here? 1, 2, 3, 4. Wait, something wrong here. Look at here. The longest carbon chain will be this. Clear? Or even you can select this one as well. You can select this one as well. Both are same thing. Check it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Both are same thing. So you can use any one. And here the longest carbon chain will be this. So once you have a longest carbon chain, then you start numbering, and numbering should start from that in where the branch get the lowest number. So here if you are going to start, the branch will be at number 3. 1, 2, 3. And if you start from here 1, 2, 3 and 4. So we will start from the bottom 1, 2, 3, 4, 5, 6 and 7. Clear? In this case again we should start from that in where the branch get the lowest. If you start from the top 1, 2, 2 has branch. If you start from the bottom, number 2 also have a branch. And then after same, then next is number 3 on both sides as a branch. So this is symmetrical compound. So you can start from any, it doesn't matter. So 1, 2, 3, 4 and 5. Clear? Let's write down the name of these compounds. So I told you in the naming system, first we have to write down the name of substituent in alphabetical order. So first you have to decide here what is my substituent or branch. So you can see number 3 have a carbon chain as a branch, and number 4 also have a carbon chain as a branch. Both are single carbon containing chain, CH3 and CH3. We all knew CH3 is considered as methyl group. CH3 is what? Methyl. So both are methyl here. Whenever we have same substituent in multiple number of time, like 2, then we will use di, 3 tri, 4 tetra, 5 penta, like that. So this is 2 times at number 3 and number 4. So in IUPAC I told you that first we have to write down the name of substituent in alphabetical order. I can again write here, IUPAC is what? Name of substituent in alphabetical order, then word root, then primary suffix and then secondary suffix. Clear? So this is the trend. So here my substituent is number 3 has methyl and 4 also have methyl. Both are same thing, so we will use di, and it present at number 3 and number 4. So we can say for substituent we can say 3, 4, 3, 4 2 times, so di, and this is CH3, so dimethyl. So this is the name of substituent. Next, word root. Word root is what? Number of carbon in a parent chain. So how many carbon we have? 7. 1, 2, 3, 4, 5, 6, 7. So we can use here hept. And after that, primary suffix. Primary suffix is what? An, in and ein. An means single bond, in means double bond, and ein means triple bond. So this is pure single bond, so we can say hept N. Clear? So this is the name of this compound, and there is no secondary suffix. Secondary suffix means functional group. Now look at this one. Number 2 has a methyl, number 3 has a methyl, and number 4 also have a methyl. Same substituent in multiple number of time. This time it is 3 times. So tri, we will use tri. and you can see number 2, 3 and 4. So we can say 2, 3, 4 trimethyl. How many carbon in a word root? 5. So pent. And then we have primary suffix is just single bond, so pentane. Clear? So this is the name of these two compounds. We can discuss few more in the alkane. Look at here. So here we have A and this is my B and this is my C. Clear? So take your time. First you had to decide the parent chain. So parent chain is what? The longest carbon chain. And here, if you are going to straight from here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7 is the longest one and we can start from here. Clear like this. And this is symmetrical, so this is 3 carbon chain is my parent, or vertical 3 carbon is also the parent chain. So now we can decide the numbering here. Now we can decide the numbering. So let's start the numbering from A. So we will start from that in where the branch get the lowest number. So let's start from here 1, 2 and 3. My first branch is at number 3 position. And if you start from the top one, 1, 2, 3. So here also we have 3 as a branch. So what we will do? Because both branch at number 3 from both side, now we will decide, and this is the different branches. This is bromine, this is methyl, this is not the same. Once you have same, then you can start from any end, it doesn't matter. But we have two different side chains, so we will give the priority in the alphabetical order. So this is bromine which starts with the alphabet B, and this is methyl which starts with the alphabet M. So B comes first, so it should be like this: 1, 2, 3, 4, 5 and 6. In this case, if you are going to start the numbering from here 1, 2, 3, 1, 2, 3, and then number 4 has a ethyl on both sides. So which one is the parent chain? So look at here. We will apply the lowest sum rule here. Lowest sum rule. What is this? We will calculate the sum of all the substituent positioning in both sides. So look at here. If you start from this end, why I am going to do this? Because we have same branches at all the positions. So look at here. If you start from this end, 1, 2 and 3. Number 3 has 2 methyl, so 3 plus 3. After that 4 has also a branch, so 4. And then 5 also have a branch. So this is from the top, from top. If you start from the bottom, then what is the positioning of the substituent? Look at here. 1, 2, 3. Number 3 plus number 4 also plus number 5 2 times branch. So 5 plus 5 like this. Clear? Now we can add them. So 4, 3, 7, 7, 3, 10, 10 plus 5, 15, 10, 14 plus 3, 17. So the lowest is 15. So we will start from the top. Clear? So 1, 2, 3, 4, 5, 6 and 7. This is the correct one. And this is symmetrical, so 1, 2 and 3 you can start from any end. Now we are going to write down the name of compound. So I said that always write the name of substituent in alphabetical order. So we have methyl and bromine, so B comes first, so we can say 3 bromo, 4 methyl. Word root is what? Hex, so hex, and ane, hexane. Clear? In the B, we have 3, 4 and 5. So look at here, 3 comma 3 dimethyl, this is 3 comma 3 dimethyl, and this is also 5 methyl, 5 methyl, and this is ethyl, this is ethyl. So look at here, whenever you have word root D and E, listen, do not consider the di, tri, tetra in alphabets. You have to consider the methyl ethyl, means this M with this E, and this is also M. So this one and this one is same thing. Why? Because same substituent 3 times, means this is number 3 2 times and number 5 have just a single methyl group. So overall this is 3 times methyl. Clear? But this is E and this is M, so E comes first. So we will write the E first. So 4 ethyl, so name will be here 4 ethyl. Now number 3 and number 5 have same substituent, both are methyl, so 3 times, 2 here and 1 here. So we will say 3 comma 3 comma 5, 3 comma 3 comma 5 trimethyl, trimethyl. What is the word root? 7, so heptane, heptane, heptane. Clear? This one is simple. Number 2 has a 2 side chain, both are same, so 2 comma 2 dimethyl, dimethyl propane. Prop is word root, ane is a primary suffix. So this is all about the alkane. Now move to the alkene. So naming of alkene. The very first selection of parent chain. Parent chain must have maximum number of double bond, maximum number of double bond with longest carbon chain, with carbon chain. And numbering I already did. Numbering is what? Start from that end where the double bond get the lowest number. Start from that end where the double bond get the lowest number. Double bond get the lowest number. Lowest number. Look at the example. So first we are going to select the longest carbon chain with a double bond. So this is my principal chain. Here this one is my principal chain because both double bond in the parent chain. And here we have this, the principal chain. Clear? So start numbering from that end where the double bond get the lowest number. So if you start from this end, 1, 2, 3, 3 has a double bond. 1, 2, 3, 3 has a double bond. So when double bond is common, then look at the branch. So 1, 2, 3, 3 also have branch. 1, 2, 3, 3 also have a branch. So this is symmetrical and we can start from any end. So 1, 2, 3, 4, 5, 6. Now first we have to write down the name of substituent. So substituent is both methyl here. And it should be what? 3, 4 dimethyl. Then word root, hex is a word root, so hex. After that primary suffix is of 3 type, ane, ene and ine. So here we have ene. and ene present at number third carbon, so hex 3 ene. Okay, so this will be the name, 3,4 dimethyl hex 3 ene. Look at this one. So this is again, we can start from both end. The double bond comes at same positioning as well as branch. No, there is a problem with the branch. Here my branch is at number, oh wait, I think I made a mistake here. Wait, okay, look at this one. So this is my parent chain. This is the number one is also double bond, and here double bond also number one. So next priority is the branch. So branch is number 3 here, 1, 2 and 3, and here branch is 1, 2, 3, 4. So the top one will be the correct one, 1, 2, 3, 4, 5, 6, 7. So name of substituent we have to write. So what is my substituent here? Substituent is here 3 and 4 dimethyl. So 3, 4 dimethyl. Word root is what? 7 carbon. So hept. Look at here, very important point. Whenever we have more than one double bond in a parent chain, more than one, then you have to use a suffix A, alphabet A in word root. Suppose we have pent, then we will use penta, but, buta, hex, hexa, hept, hepta, whenever we have more than one double bond. So you can see we have more than one double bond here. So hept is my word root. So we can say hepta. And then number 1 and number 6. Number 1 and number 6 have double bond. So we can say 1, 6 diene. 2 double bond. That's why we are using diene. Okay. So this one is this. Now the last one. This is my numbering 1, 2 because double bond get the lowest. So 3, 4, 5, 6. So as you can see 3 and 4 have dimethyl. So 3, 4 dimethyl. And then hex 2ene. Hex 2ene. Okay. So this is the alkene one. Alkyne is same like alkene. The difference only in the primary suffix. In place of ene, we can say ine. So let's discuss an example only. The naming of alkyne. Naming of alkyne. Everything is same. So we can say here, suppose this is the example. A, and this is this one, suppose. Look at this one. This time we have both ene and ine. I think these two are the good enough. Here we can use bromine. So look at here. First of all, select the parent chain. So this is my parent chain. And then numbering start from that in where the triple bond get the lowest number. So 1, 2, 3, 4 and 5, 6. First we have to write down the name of substituent in alphabetical order. So B comes first, then methyl. This is methyl. So we can say 4 bromo, 3 methyl. Word root is hex, so hex. Number 1 has triple bond, so hex ine, or you can say hex 1 ine. Both are correct. Hex 1 ine or hexine or 1 hexine. Everything is correct here. In this case, this is my parent chain because both double and triple bond in the parent chain. And whenever the parent chain has double and triple both. So I said that, and both are at same number. Both, one here, one here. If you start from top or bottom, both are my 1. So I said that in the numbering rule, the first priority is given to functional group, then double bond, then triple bond, then substituent. If you look at the slide. So both are at number 1. So priority is given to double bond because it starts with the alphabet E, ene. And alkyne starts with alphabet ine, Y. So E comes first. 1, 2, 3, 4, 5, 6. So 3, 4 dimethyl. 3, 4 dimethyl. Then hex 1 ene. E comes first, so 1 ene and 5 ine. 5 ine. So look at one more thing. If you write down the ene and then you are going to write 5 ine yne. So look at after E, if you have A, E, I, O, U, then remove this E. It should be only En 5 ine like this. The name will be 3, 4 dimethyl hex 1 in 5 ine. So this is alkyne. The next is naming of cyclic compounds, cycloalkane and cycloalkene. So naming of cycloalkane and cycloalkene. Look at here, we all knew if you have a 3 carbon ring like this, then this is called cyclopropane. And if you have 4 carbon ring, this is called cyclobutane. And 5 carbon ring is cyclopentane. And this is cyclohexane. Clear? Because 6 is hex. This is cyclic, so cyclohexane. Because everyone is single bond, so cyclohexane. Look at this is called cyclo. So we have to use a prefix cyclo. 3 carbon prop, everyone is ane, so propane, cyclopropane. This is cyclo, 4 carbon, so butane. 5, so cyclopentane. And this is cyclohexane. Look at the naming of like this. In this way. So here we have 2 compound A and B. So look at here. We all knew we have the double bond and substituent in the compound number A. Double bond and substituent. So numbering should start from that in where the double bond get the lowest number. Means priority is given to the double bond. Because principal chain is very clear. The ring, entire ring containing carbon is my principal chain. This is the principal chain. Now we have to start numbering in the principal chain from that end where the double bond get the lowest number. So look at the possibilities. I can again copy the same compound. So if you are going to say suppose this is my 1, then 1, 2 will always be on the double bond, always. So this is 1, this is 2. Clear? If suppose this is my 1 and this is 2 and this is 3, then clear? So let me know which one is correct according to the priority order. So double bond must be the lowest. So here double bond is 1 and here also double bond containing carbon is my 1. So this is common factor. Second, the branch. So here branch at number 2 and here branch at number 1. Can you see? So this, the bottom one is the correct one. So 1, 2, 3, 4, 5 and 6. So we have to write down the name of substituent in the alphabetical order. So this is ethyl, 2 carbon chain, ethyl, this is methyl. So alphabetically E comes first. So we can say 3 ethyl, 1 methyl, 6 carbon chain in the ring. So cyclohex. 1 has double bond. So cyclohexene or 1-ene. Both are correct. Clear? In this case, same here. I can again copy the same compound like this. If this is my 1, then it should be 2. Then 3, then 4, then 5 and then 6 like that. So you can see double bond is definitely at number 1, but my branch is at number 5 and 6, which is too far from the double bond. And if we are going to start this one, 1, 2, 3, 4, 5, 6, this is the correct one, because again my double bond is on the lowest one, but after that the branch is at the lowest as well. So the right structure is correct. So name of substituent in alphabetical order. So B comes first. So 3-bromo, 3-bromo, 4-ethyl, 4-ethyl, cyclohex, cyclohex, 1-ene. Okay, so this will be the name. So this is all about the cycloalkane and alkene. Now we are going to start the naming of functional group. Naming of functional group. Very important one only. The very first one is a carboxylic. COOH. Its secondary suffix or IUPAC name is oic acid. Oic acid. What is the selection of parent chain? SPC means selection of parent chain. So parent chain must have carboxylic with longest carbon. Carboxylic with, if double bond, then you have to double bond include in the principal chain, but carboxylic must be in the present chain, parent chain with maximum number of, then you can use this priority: double bond, triple bond, and substituent. Maximum number of carbon. Maximum number of carbon means carboxylic is my functional group, so it should be in the chain, and then you have to include all these in the maximum number. Numbering rule, this is very, very important, because carboxylic group has a carbon, so always give priority to that carbon. Okay, so we can say start numbering from the carbon of carboxylic. Carbon of carboxylic. Now look at few example. Like this. So first is what? Select the parent chain with maximum number of carbon as well as functional. So this is carbon of functional group, and this is my longest carbon chain. So first priority is what? Substituent in alphabet order. So first we have to start numbering. This is 1, this is 2, this is 3, this is 4, this is 5. So 2-bromo, 2-bromo, 4-methyl, 4-methyl, and then 5 carbon chain is my parent chain. So it should be pent. Pent-2-ene, pent-2-ene, and 1 oic acid, 1 oic acid, because carboxylic is called as oic. So pent-2-ene, 1 oic acid. Clear? I think this is good enough, one example, and there is no need to memorize the secondary suffix of the functional groups and all. It will always be given in the system sometimes. If the question is directly related to IUPAC, then. If it is not related to IUPAC, suppose you have a reaction and then in the options you have the name in the IUPAC system, then you should know that one. And there are some questions based on reactions with the naming. Okay. Now the next one is naming of aldehyde. Naming of aldehyde. This is called CHO group, which is my aldehyde. Secondary suffix is called as al, and its common name is called as oxo. I will tell you what is the role of common name. So first thing is selection of parent chain. Parent chain must have aldehyde. Parent chain must have aldehyde. Must have aldehyde with longest, with maximum number of double bond, triple bond and substituent. Numbering rule, always start from the carbon of aldehyde. Numbering start from the carbon of aldehyde. Carbon of aldehyde. Look at the example. So this is my parent chain, this is carbon. So like this. Okay. Numbering should start always from the carbon of aldehyde 1, 2, 3, 4 and 5. Name of substituent in alphabetical order because both are same. So 2, 3. Oh no, this is not same. Here 2 carbon chain, this is ethyl and this is 1 carbon chain which is methyl. So we can say 3 ethyl, 2 methyl, pent, 3 ene. Word root is my pent, primary suffix is ene, so pent 3 ene and 1 ul. You can see again I removed the E and E, the last of E in ene because there is A. Okay. Here this is my parent chain. 1, 2, 3, 4, 5, 6. Name of substituent in alphabetical order. This is bromo, so B, and both are my methyl, so B comes first. So 3 bromo and then 2, 4 dimethyl, 2, 4 dimethyl. After that hex 4 ene, and 1 ul. Okay, so this is aldehyde. Now the next one we can discuss naming of ketone. Naming of ketone. So selection of parent chain. Ketone must be in the parent chain. Ketone must be in the parent chain. In parent chain. Second thing, numbering rule. Start from that end. This time I am not saying start from the carbon of ketone. No. Listen, what the difference between aldehyde, carboxylic and ketone? Aldehyde and carboxylic always be in the terminal position in the principal chain. Always be in the terminal. But ketone will always be present in the between the carbon chain, not terminal. Okay. So if you have a between the carbon chain, it means you should start from that end where ketone get the lowest number. So we can say here start numbering from that end, start from that end where ketone get the lowest number. Like this. So first you have to select the longest carbon chain with the ketone. This is my longest carbon chain. And then start numbering from that end where the ketone get the lowest. Here 1, 2, 3, 4, 5. And here 1, 2, 3, 4, 5, 6, 7. Clear? So number 3 has ketone. So name of substituent in alphabetical order. So 4 bromo, B comes first. Then 5 methyl, and then hept, and after that 4 ene, and then 3 one. 3-one. So just remove this E. 3-one. Okay. So this is the naming of ketone. Ketone IUPAC name is one. Ketone IUPAC name is one. I can write here. Secondary suffix is called as one and common name is oxo. Oxo. Clear? So the last one now I am going to discuss the naming of alcohol. So these four are the very important one and there is no need to memorize the rest functional group and its property. It will always be given in the stem. But these four are the very important one. Okay. Aldehyde, carboxylic, ketone and alcohol. So let's discuss the naming of alcohol. Selection of parent chain. So parent chain must have alcohol. Parent chain must have alcohol. And the rest rule you have to follow, means it should be longest carbon with maximum number of double bond and all. Now next is numbering rule. So in numbering we can again say, because alcohol is again present between the chain, not terminal. So start from that end, where alcohol get the lowest number, gets the lowest number. You know, alcohol common name is called as hydroxy and IUPAC is called as all. Okay, so we have example. This one. So this is my longest carbon chain and start numbering from that end where the OH get the lowest. So 1, 2, 3, 4, 5, 6, 7. Alphabetical order, look at here: B bromo, C chloro and then M for methyl. So B comes first, so 3 bromo, after that 4 chloro, then 5 methyl, and then hept 3-ene, and 2-all. Clear? So this is the naming of alcohol. Sometimes we have a multiple functional group. Look at here this example, this one. Sometimes we have multiple functional groups, so what we have to do? So in this case, the high priority group is considered as the main functional group and the rest of the functional group will be the substituent or branch. Clear? And no need to memorize which one has high priority because it will always be given in the table, the stem. So suppose I am saying here carboxylic has more priority than alcohol, because here we have two functional group, carboxylic and alcohol. So carboxylic will be my main functional group and alcohol is treated as a substituent or branch. So we have to include the carboxylic carbon in the principal chain like this. Makes sense? And then start numbering from the carbon of carboxylic. So this is my main functional group. So 1, 2, 3, 4, 5. So the main functional groups secondary suffix we will use, and this one we will use its common name. So alcohol common name is what? Hydroxy. So look at the alphabetical order. This is 2 carbon chain, so which starts with alphabet E, ethyl. This is methyl, M, and this is hydroxy. So E comes first, so we can say 2-ethyl. After E, I think H, so 4-hydroxy. And then 3-methyl. and then word root pent, primary suffix is -ene, so pent to -ene, and then one oic acid, one oic acid. Clear? So this is the name of multiple functional containing compounds. I think this is good enough for the naming one. Rest you can practice yourself. If there is additional functional group, it will always be given in the stem and you can easily do this. This is the basics rule of naming. Okay. So let's discuss questions. So look at this question. Look at this question. What is the correct IUPAC? I think it is visible. I can zoom this as well a bit more. Yeah. Look at the very first question. What is the correct IUPAC name of each of the compound in the question 1 to 5? So this is the compound, and first of all we have to select the longest carbon chain because there is no double bond and all. We have just a carbon chain, so it's your job to figure out the maximum number of carbon. So look at the options. It is saying hexane, it is saying heptane, heptane and octane. So there is a one option in which you have octane, 8 carbon chain. So there is any possibility through which you can identify 8 carbon is my principal chain. Always go with the maximum one very first. So look at here, if you start from this end, either this in bottom, because both are same here after the branching. So and then you can move like this, suppose. Is there any possibility like it? So 1, 2, 3, 4, 5, 6, 7 and 8 I think. 1, 2, 3, 4, 5, 6, 7. No, not possible yet. Okay. Again try this one. Suppose 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this one. Wait. I'm talking about you should start from this end and then go like this. This one. 1, 2, 3, 4, 5, 6, 7 and 8. So this is the 8 longest carbon chain. So option D is right. No need to write down the entire name of the compound. It will save your time. Okay, always go with the options. If you think something wrong, then eliminate. And if you think, yeah, it's okay, then move on. Okay, so this is the way to eliminate the options. If you want to write down the name, you can go with the alphabet order. You can see if you start numbering from this end, so number 3 has a branch, and if you start numbering from this end, it will be 1, 2, 3. Number 3 also. Clear? And then the next branch is here at 4, and here next branch is number 5. 4 and then 5. So 4 will be the correct. So 1, 2, 3, 4, 5, 6, 7 and 8. Clear? So the name should be in alphabetical order. So E comes first. So ethyl is at number 4. So 4 ethyl. 4 ethyl. And then 3, 6 dimethyl. 3, 6 dimethyl. And then heptane, octane, sorry, 8 carbon chains, octane. Octane is only in the option very last. There is a few mistake here. You cannot write D. Listen, between D and E, you cannot compare D with E. You have to compare the M part with E. And E comes first. So the correct name should be, it should be like this: 4 ethyl, then 3, 6 dimethyl. It's just a very minor mistake here, okay? Because always compare the word root alphabets, not di, tri, tetra, okay? But this is the very close to the right choice because octane is only in the option D. Now move to the next. Okay, so look at the options. Look at the options. We all knew whenever we have more than one double bond in the parent chain, then we can use a prefix a suffix A, like buta, penta, hexa, like that. So buta, hexa and hexa. So you can see between but and hex, the longest carbon is hex. So priority, maybe the hex is correct because this is the longest carbon chain. You can select. Clear? 1, 2, 3, 4, 5 and 6. If you go above to the chain, this is again 1, 2, 3, 4. Here 5, 6, the above one is also 5, 6. So you can select any one, it's your choice because both are same thing, 2 carbon and 2 carbon, this one as well. So now if you are going to write down the name, you can see 4 has ethyl, so 4 ethyl. So this is hexa. Hexa 1 comma 3. Hexa 1 comma 3. Hexa 1 comma 3 is only in the option C. You can see this is 3 5 hexa, which is wrong. Okay, no need to move further. You can eliminate the answer and just move on. Question 3. Hexanone, hexane, cyclohexane. This is wrong. The reason is that we all knew whenever we have a functional group, ketone, this is so on. And how can you find out the functional group? I think it will be given in the stem. Oh no, functional group information is not given here. So this is a very basic. You must have to memorize what is ketone, what is aldehyde, what is alcohol. Okay, maybe in the next page. So look at here, this is ketone, so it should be hexone. On must be there, and hexanone is only this. So this is wrong. Hexane, again this is wrong. Now start numbering from that in where the ketone get the lowest. So this is the way you can start 1 and this is 2. So the name will be then 3, 4, 5 and 6. So 2, 2 dimethyl. 2, 2 dimethyl. Cyclohexanone. So C is right choice here. 2, 2 dimethyl 1 oxy, it is saying you cannot use oxy. Oxy is a general name, common name of ketone, and we can only use once you have a more than one functional group. But here you have just one. Now look at this one. The preference is given to double bond. So 1, 2 and then the longest, the branch which get the lowest number. So 3, then 4, then 5 and then like this. So B comes first alphabetically. So 4 bromo. 4 bromo is only option A. That is right choice. Simple. Very easy. No need to write the entire name. Just you can check in this way. Clear? Now move to the next one. So you have here table. Okay, you have the table here. Look at this one. This is my carbon, 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 carbon and carbon. Look at, always start from that in where the double bond get the minimum number. So this is my parent chain, there is no doubt. Because chlorine is not the part of parent chain, carbon is only. This carbon has a double bond, so it should be my 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Clear? And the name should be what? 7. 7 means hepta. So hepta is here, hepta is here. And it should be double bond at 1 and 5. So hepta 1 comma 5. Hepta 1 comma 5 is only in the option B. Simple. Clear? So this is the table in which you have some functional group and its priority order, as well as their suffix name as well as common name. So now look at this question. Which of the following structure represent 3-oxobutanol? 3-oxobutanol. Butanol means but is my word root. 4 carbon. Al means aldehyde. Oxo is common name of ketone. In the table you can see. Clear? So 4 carbon with ketone and aldehyde. Look at here, this both are aldehyde, so wrong. This is aldehyde, this is ketone. Yeah, perfect. Now start numbering 1, 2, 3, 4 and 5. So here you have 5, not 4, because butanol means 4 carbon chain overall in the principal chain. So this is wrong. This is aldehyde, this is ketone, which is fine. So numbering 1, 2, 3 and 4. This is correct. Because you can see number 3 has oxo. Number 3 has oxo. Number 3 has ketone, so oxo. 4 carbon is a parent chain, so butane, and aldehyde is al, so butanol. So C is right. Clear? Now move to the next. Okay, it is saying structure represent 2-ethyl 4-hydroxy pentanoic. So pentanoic, oic means carboxylic, pent means 5 carbon in the word root, hydroxy means 4 group has OH, clear, and number 2 has ethyl. So carboxylic and alcohol, look at carboxylic is my 1, so number 2 is OH, so this is wrong because it is saying 4-hydroxy. So OH must be at number 4th position. So look at this one, 1, 2, 3, 4, 5. Yeah, this is 4-hydroxy. 1, 2, 2-hydroxy, wrong. 1, 2, 3, 4, 5 and this is 6. This is again wrong. So 4-hydroxy is only option B which is correct. Clear? No need to check the entire name. If you want to check, name of substituent comes first. So 2-ethyl, you can see 4-hydroxy pentanoic. Now move to the next. Correct name for this. So this is alcohol and ketone. We don't know which one has high priority, so we will see the table. Ketone and alcohol. So you can see, if you look at the priority precedence, so highest is my ketone, then alcohol. So we will use the ketone on and alcohol hydroxy. Clear? So 1, 2, 3, 4, 5. The name will be 4-methyl. 4-hydroxy. Pent-2-on. So 4-methyl. Oh, let me check this again, the priority. Ketone has high priority, no doubt. Lowest is my alcohol. So if ketone is my lowest, so 1, 2, 3, 4, 5. So it should be 4-methyl. 1, 2, 3, 4, 5. So 4-methyl, 4-hydroxy. Yeah, this is correct. 4-hydroxy, 4-methyl. Oh, I made a mistake here because H comes first. So you should write like this: 4-hydroxy, then 4-methyl. 4-hydroxy, 4-methyl, pent-2-on, and this is pentanone. It should be pentane-2-on, not pentanone. Okay, because ketone at present number 2, and this is well understood as well because ketone always be between the chain. It cannot be in the terminal. So if it is terminal, then 1-on, but ketone never be in the terminal. That's why you can say after that carbon means 2-on. So you can say 2-on or on, that is fine. So this is all about the naming of compound, and I have discussed most of the cases with examples. So please watch the video and try some of the questions from yourself. Thank you so much.